Hello, everyone. I am back here again today to continue reading to you from the book that we read last time. I got it from my mama. Um, Gregor Mendel Explains Heredity. So this time I thought that I would have the book up on my screen here and then you'd be able to read along with me as I read it to you. So we left off last time by stating that Gregor Mendel had three discoveries when he was researching heredity and genetics with the pea plants. So from what he saw among the pea plants, Mendel proposed three laws: the law of segregation, the law of independent assortment, and the law of dominance. So we are going to talk about some of these things here today. So I'll just go through some of this vocabulary here. We know what dominance means. That means that some traits are more dominant than others. Remember that the stronger traits are dominant and the weaker traits are recessive. Okay. The word segregation here means pretty much like the word separation, that different traits are independent of each other. For example, your brown hair and your brown eyes, or your blonde hair and blue eyes, they are independent of each other. You get them separate from each other. You do not, they are not connected. And then independent assortment means that you can get any combination of these traits. So let's keep these things in mind as we read today. Okay, here is a picture of experiments on plants taking place, and they're just growing them in test tubes so that the traits can be studied. Now this is interesting because we had looked at Punnett squares uh, in the past, but if you look here, this table is showing us a much more detailed Punnett square. So I want to just talk to you a little bit about each part of this. So here at the bottom we see different traits. Okay, the R, the big R here, stands for the green trait, and the little r, the recessive, stands for the yellow. Okay, so we know that green is dominant, R is recessive. Then over here, if you look at the pod shape, the um, the big Y represents the bumpy pod shape, and the small y represents the smooth pod shape. Okay, so if you look here, you can get yellow with smooth. You can get green with bumpy, and if you look, green and bumpy are 3/4 likely to come out in this case, but you also have to consider all of these different combinations. So green and bumpy has 1, 2, 3, 4, 5, 6, 7, 8, 9 chances out of the 16 to come out. Green itself has 4, 5, 6, 7, 8, 9, 10, 11, 12 chances to come out. And yellow only has 4 chances, and yellow and bumpy have 3 out of the 16 chance. And this is the rarest one here, the yellow and smooth, very unlikely to come out, only 1 out of the 16. So this is independent assortment and segregation, and it's taking into account two different traits, two different genes that can take place, similar to, like I said, hair color, eye color, or height and hair color. They're different. They're independent of each other. They're not connected. So here is the description of the law of segregation. This law states that genes are in pairs. For example, P and P, P and R, or R and R. Remember, we get 2 alleles from our parents. We get one from our father and one from our mother. That's every single trait. We get 2 different alleles, and one of them comes out and one of them doesn't. And each each parent passes on to its offspring only one half of that pair. So for a parent with a P plus R leaf instruction, it could pass on the P or the R part. That half of the instruction joins with the half the other parent provided to provide a gene pair for the offspring. Like I said, your brown hair, you might have gotten 2 brown alleles, but you might have also gotten a brown and a blonde. And the brown would be more likely to come out, more dominant, 3 out of 4 chance. But it's not connected with your eye color or your height or anything like that. The law of independent assortment. The law of independent assortment states that trait information is independent of the information about other traits. If the parent pea plant is passing on instructions about seed shape and seed color, for instance, the half of the instruction pair that it passes on for seed shape is independent from the half that it passes on for seed color. Here is another similar chart to the one that we saw before. Now, if you look here, we're looking at the seed shape and seed color. 9 out of the 16, again, 9 out of 16 will come out yellow and smooth. 3 out of the 16 will come out yellow and bumpy. So that means that 12 will come out yellow and 4 will come out gray. The rarest one here is the gray and the bumpy. That's because both gray and bumpy are both recessive traits. So it's highly unlikely. Instead of being 1 out of 4, 4 times 4 is 16. So it's 1 out of 16 for that very recessive seed, color, and shape combination to come out. So this is math, it's fractions, it's probability. Here is discussing how genetic disorders can be passed down. So if there's a father that is affected with a genetic disorder and there's a mother that is unaffected by a genetic disorder, then if you look here, you could have different combinations. You could have a son that is affected, or you can have a son that is not affected. You could have a daughter that's not affected, but you could also have a daughter that is affected. So genetic disorders can be genetic as well. Certain types of diseases and disabilities too. Here is the law of dominance. To go back to our simple example, if the child plant receives the mixed instruction P plus R about leaf shape, and if P is the dominant trait, then the child plant's leaves will tend to be pointy. The P stands for pointy. And when it says that it would tend to be pointy, that means that it's the possibility is greater, the probability is greater. It's 3 out of 4, 75% chance to be pointy, and only 1 out of 4 to be, what was the other? Smooth, I guess. Mendel bred together plants with yellow peas and plants with green peas. He found that the next generation of plants produced all yellow peas, but that in the generation after that, about 1/4 of the plants produced peas that were green. So in the second generation, similar to when we talked about the height of pea plants, the second generation, this sort of reinforced his studies that there are dominant traits. The first generation, all yellow plants were grown. Well, actually, the second generation, but then the third generation, the green plant started to crop up again, and that shows that the yellow plants from the second generation did carry that recessive green trait, even though they did not have green peas. So that can happen if you have two parents with blue eyes. They could somehow carry an allele for brown eyes, but it's rare. So you could be born with brown eyes even if both parents have blue eyes. Here is just a picture of some peas, yellow and green. And then here is a simple Punnett square. Remember, Reginald Punnett came along later, so he created these squares, but it definitely reinforces Mendel's studies. So here we know what we're looking at if we've seen the video from the video that I posted about the Punnett squares. All right, we have yellow. Yellow is the dominant trait, okay? But this parent pea plant carries the green trait. So consider this like the blue eyes. And this parent here carries the dominant yellow and the recessive green. So we have 3 green alleles in this shape and only 1 yellow, the dominant yellow. So you would think maybe, okay, that means 3 out of 4, 75% chance to come out green, but it's not true. What's true here is that when the yellow mixes with the green, most times, 99%, you'll have the yellow dominant trait come through. Same thing here, the yellow with this green, and now you have two yellow, and then yellow and green here, and green here. So here's your 50% chance to be green, and here is your 50% chance to be yellow. If you combine, like we were talking about brown eyes, when all of the world's people have 80%, 79% brown eyes, and then only 20% make up all the other colors. So this type of Punnett square helps to explain that, because if you look at these these green characteristics, which is like the blue eyes, um, it only comes out 50%, even though most of these parents had that green allele. And then if you have parents with brown eyes, sometimes if they both have brown alleles, brown, 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 that's 100% going to be brown, most likely. So the dominant trait does come out, especially with eye color in the world, 79% of the time. He concluded that gene for the color yellow was dominant over the gene for the color green, but that a quarter of the time the new plant received two recessive green instructions from its parents. These laws are now known as Mendel's laws of inheritance. Mendel's influence. Mendel published the results of his studies in 1865, and in general the scientific community rejected them. This was partly because Mendel was not a university professor with lots of titles, and partly because what he found ran against the general understanding at the time about inheritance. So he was revolutionary because he went against common thoughts. And so because of that, and because he was not a college professor, he was a monk, he was not respected. His research was not as respected. Here is a statue of Gregor Mendel. Remember, he was born in Europe, what is now known as the Czech Republic, so this is probably somewhere over there. Here is a stamp, I believe. Is there no caption, but this looks like a stamp, or it could be some type of money with Gregor Mendel on it. And you can see here some of the trait variation being represented in a little bit of a Punnett square here. At the time, people thought that the parents' genetic material was sort of blended together so that the offspring received everything from both parents in a new mixture. Mendel's laws ran against this understanding, and it makes sense that that wouldn't be the case, because what color would you get if you blended brown with blue? Brown and blue don't really mix. You'd get probably a lighter brown, but if you think about hair color, using myself as an example, my mother has very dark hair, my father has lighter hair, but I didn't get a blend of that. I got the very dark hair from my mother's side of the family, and actually most of my traits, although they're independent of each other, I did get most of my traits from my mother's side. And on the other hand, my sister got most of her traits from my father's side. So this is all really interesting things. Mendel's church responsibilities took more and more of his time, and he had less time for research. He became abbot, the head of his monastery, in 1868, and spent a lot of time in administration and in legal disputes between the monastery and local governments over taxes. Here is Gregor Mendel again. No caption. After his death in 1884, the new abbot burned most of Mendel's papers, including his research notes and letters. This was mainly to get rid of material related to various tax disputes that had now been settled. Nobody realized that his research materials would have been useful for future scientists. That's why we see this picture here of papers being burned. This is a picture of Hugo de Vries, who I'm assuming was, there's no description in the book, so I'll have to look up who he is, but he was probably another researcher that followed Gregor Mendel. Some 20th century Scientists doubted Mendel's results and felt he must have made them up or changed them to fit what he wanted to see. This is known as confirmation bias. However, other researchers have duplicated 20th century is the 1900s. Other researchers have duplicated Mendel's experiments and have found no reason to think that Mendel was not reporting accurately what he saw among his pea plants. By the 1930s and 1940s, scientists were combining Mendel's insights with Charles Darwin's theories of natural selection and the discoveries of other researchers to develop the modern science of genetics and the modern understanding of inheritance and heredity. Now, Charles Darwin, we will learn about in future units this year, and he happens to be my favorite scientist. And he studied animals, and his theories are the basis for what we know as the theory of evolution. And he provided a lot of evidence for the theory of evolution, which we will discuss in our last science unit. Here is Charles Darwin. Here is a family of people. If you look, the father has browner hair. The mother a little bit lighter blonde, and the children were born here with blonde hair, which is a more recessive trait. Heredity affects us all. Who you are in part depends on what you inherit from your parents, and that you are very like one of Mendel's pea plants. Of course, the resources and opportunities you have and what you do with what you inherit combine with your genetic materials to make the interesting person that you are. This page is important to focus on here because, sure, we get some innate or things that we are born with that help us become the person that we are. Partially our personality. Some people can be more shy than others naturally, but our environment also affects these things. And of course, remember to maintain a growth mindset, because if there's something that you think that you can't do, you have to work hard on those things to make sure that you are working towards success. So people aren't just born with math skills. People aren't just born with reading skills. Sure, it may come a little bit more naturally to some people, but everybody is capable of finding success in these things with hard work. Here is a young girl studying some atoms or some molecules that make up our bodies, proteins. Understanding heredity helps us to understand how life develops and how new species come to be, but it is just one part of the puzzle of life on Earth. So here they're recommending to read more baby professor books, like Where Did You Get Your Hair Color? Where did you get the color of your eyes, to understand more? And we may read that, and we'll see. Okay, so I believe that's it for today. So some key takeaways that I wanted to just review quickly were that Gregor Mendel came up with 3 laws through his research. The law of segregation, meaning that all traits are separate from each other. They are not connected. Even if you think about eye shape and eye color, they're independent of each other. And the law of independent assortment reinforces this. You would get a combination of traits, and then the law of dominance, meaning dominant traits generally come out 3 out of 4 times. And this picture sort of reinforces the law of independent assortment. The way that they are assorted, the traits are independent of each other, and you can get a combination of traits. All right, that is just about it for today. I hope that you enjoyed this, and we will continue working on heredity as we move forward. Have a great day.